Welcome back for the last in the series of how to do those wonderful worksheets on structures of hydrocarbons. And today we're doing the cyclic ones. And cyclic ones, usually it's as simple as writing cyclo in front of it when you see it's curled back on itself and made a continuous loop. So here's propane, for example. And if we saw this rather difficult to make molecule like that, that would be cyclopropane. Now normally we see these in a slightly bigger structure, such as a 5 pent ring or a hex ring, and we're kind of used to showing that sort of form in sugars such as fructose and glucose. But if we just do 1, 2, 3, 4, 5, 6, there's our hexane, and of course our cyclohexane begins to look like that. So it's pretty easy. You can get cyclooctane and cyclodecane and cyclododecane, and all of the others can be cyclic. But the naming gets a little more complex when we do two things. One, when we start to add functional groups to them, and two, we can add multiple bonds, such as here and here, where you obviously get that one is going to be an ene, and that one is going to be an yne of some kind. So let's have a look how we do this. So here we've got cyclohexane, and we can add a methyl group to it. And what this would be, well, the numbering starts from the most interesting feature on the ring. So usually if it's a double bond, we're going to start the numbering from there. So that would be 1, that would be 2, 3, 4, or indeed 1, 2, 3, 4, whichever way we decided to go. And here's cyclohexane, but it's methyl cyclohexane. And there's no particular need to put a number on it, but we usually call the most interesting feature number 1. So we could call that 1 methyl cyclohexane. There's no real reason to do that. We could also do this. Now the most interesting feature is probably the ethyl. So that would be 1 ethyl, 2 methyl cyclohexane. Get the idea? Let's see what we might do if we made that hexane. Let's get rid of some of these things. If we made that hexane into a hexene for fun. So we'd go like this, and we'd add an ene there, and that's obviously cyclohexene. And there's no particular reason to say hex-1-ene, even though that would be 1, 2, 3, 4, or we might do it the other way, 1, 2, 3, 4. And how would we do that? Let's have a look at here. Oh, let's make it a propyl group for fun. So with this one, we'd start from here, and so that would be 3 propyl cyclohex-1-ene, but the 1's not necessary. So that's basically the way we name the cyclic ones. Usually it's as simple as putting cyclo in front of the other normal name. If it's got functional groups, you've got to do something else to it. So let's have a look at some of the ones we've got, such as this one. So the first thing we do is look at the ring. 1, 2, 3, 4, and that's bute. Only single bonds, so it's ane. And then we have to work out how to number them. So that's probably the most interesting feature here. 1, 2, 3, 4. And so that will be 1 ethyl, 2, whoops, not 2, it's 3 methyl butane. Nice. There would be nothing really wrong with numbering it this way, 1, 2, 3, 4, and calling it 3 ethyl 1 methyl butane. I don't think anyone would fault you for that, but this is the more normal way. Let's have a look at this one, because this gets complicated by having a double bond in it. So, first thing to look at is the ring. The ring has 5 carbons in it, and so you'd call it pent. But now you'd start looking at this one and looking at where the double bond is. So it's ene. Now at this point, you might put a 1 in there because you start the numbering where the 1 is. But you can see that because you actually start the numbering where the 1 is, there's not really much point in putting that 1 there. So you could just write pentene if you liked. This one would not be wrong. This one is kind of more usual. And so we start counting now towards the lowest number where the more interesting feature is. So you go, here it is, 2, 3, okay, 4, 5. So what we've got is, and number 3, we've got 3, 1, 2, 3, propyl. Count round again to 5, where there's an ethyl, pentene. Make sense? Hope so. And now let's look at the last one, which should be fairly easy, even though I've drawn it very badly. The last one I'm going to do is number 8. And so number 8 is clearly an yne, because it has a triple bond somewhere in the ring. The ring is 1, 2, 3, 4, 5, 6. It's a hexagon, so it's hex. Yne. And once again, we could write hex 1-yne, or we could just write hex yne, because we start the numbering from the double bond. And we look at where we'd go from that, and we'd go 1, 2, 3, 4, and there's a 5 and a 6. And attached to the hex ring, we've got our 4 methylhexyne, or 4-methylhex-1-yne, if you like. And there's only one more I want to do because it's in the second column, and we may as well do one from the name to the structure. So let's rub this out. And the one I want to look at is number 23. And number 23 is 3,5-dimethyl cyclohexene. And you notice they haven't bothered to put hex 1-ene. It's simply that you know we're going to start the numbering from the double bond. So the first thing we draw is a hexagon. Very pretty. We put the double bond wherever we want, and we start numbering 1, 2, 3, 4, 5, 6. And then we see that on the 3rd carbon and on the 5th carbon, there are methyl groups. And that's it. So, good luck with the cyclic hydrocarbons. They're not particularly difficult, but they look like horrible things. So, all the best. And that will be the end of that huge 3-page assignment sheet. Good luck, and I hope to see you soon.